Hello, my name is Victoria, this is Isabella, and this is Cora.
We are Team 1305, the Dhahran Wildcats.
And we are here for the robot design presentation.
Our Saudi FLL team is made up of people from 4 different scrimmage teams that compete against each other in other competitions that we organize. Although we're from different teams, we all have roughly the same strategy. Longer runs and attachments covering high scoring missions and using the leftover time to do shorter runs that score fewer points. By observing how each team completes their missions, we have discovered that runs that score more points while completing multiple missions with one attachment are most efficient. In the club, we share many ideas and skills, even though we are competing with one another. Skills such as a new gyro turns, true north, and driving straight using a gyro, making our robots more precise.
Each sub-team built its own robot from scratch without taking any references from past built robots, ensuring the design fits the strategies used to complete the missions. We experimented with different designs, optimizing as many as possible. We chose to use the robot to score the highest points in the scrimmage and the all-around field that we hosted ourselves. With over 80 people in the club, it was sometimes hard to get work done. So teams came in after school, during breaks, or on the weekends to get more work done. And with the help of our coaches, Mr. Russell and Ms. Martiza, we got the guidance we needed to improve.
Our team made attachments that can be used for multiple missions while also coding the robot according to our mission strategy, completing multiple higher scoring missions using long runs and using shorter runs to do lower scoring missions. Whenever our team finishes building and coding a run, we always test it at least 3 times to make sure it's consistent. This way, it also helps us find bugs in the code or potential things that could make the run go wrong. Something that teams have discovered was that sometimes the robot would drift while driving straight. To solve this problem, we added a gyro sensor to the code. This way, it helps keep the robot on track in a straight line and allowed us to code the robot to drive at specific headings.
As our team was made up of 4 different teams, everyone had their own robot design process. However, one thing was very similar. We all made robots from scratch without using any references from online. Some examples from each team were the 2 motors that could have 4 attachment points for our attachments. So one of the visualizations of optimization was this. So we have one team's attachment and another team's attachment, and you can see they're a little bit similar, but also different in design, as this team used chains while this team just used a straight axle. And this team had a more complicated setup in terms of this, and it's a little bit more stable than this. After 2 competitions, the scrimmage and the all-around club that we hosted ourselves, we decided we would use the robot that based on the performance at the competitions. Although we were all from different teams, we shared robot ideas and coding concepts with over 42 teams at the 2 scrimmages. As we feel the robotics here is somewhat better and we really want to develop it.